Imagine teaching a child to identify animals. At first, you show them pictures of cats and dogs pointing out the differences. Over time, they learn to recognize these animals on their own, even in new contexts. This is essentially what machine learning, ML, does, teaching machines to learn patterns from data and make decisions without being explicitly programmed. So, what is machine learning? It's a subset of artificial intelligence that focuses on building systems that learn and improve from data. Rather than programming specific instructions, you train a model with examples, allowing it to identify patterns and make predictions. For instance, a spam filter learns to identify unwanted emails based on previous examples. A recommendation system like Netflix learns your preferences by analyzing what you've watched and rate it. Machine learning is like having a self-improving assistant. It gets better with experience. Machine learning can be divided into three main types, each tailored for different problems. Supervised learning. Think of it as learning with a teacher. You provide labeled data, e.g., pictures of animals labeled as cat or dog, and the model learns to classify new data based on those examples. Examples: email spam detection, fraud detection. Unsupervised learning. Here, the machine has no teacher. It explores unlabeled data to find patterns and groupings, much like discovering clusters in a puzzle. Examples: customer segmentation, anomaly detection. Reinforcement learning. This is learning by trial and error. The model interacts with its environment, learning from rewards and penalties to achieve a goal. Examples: self-driving cars, game-playing AI. These approaches make machine learning adaptable to a wide range of tasks. Let's look at the foundational concepts that power machine learning algorithms. These are the mathematical recipes that process data and make predictions. Examples include linear regression, predicts continuous outcomes, e.g., housing prices. Decision. Trees. Classifies data into categories, e.g., whether a loan applicant is eligible. Evaluation. Metrics. Tools like accuracy and precision assess how well the model performs, ensuring it's reliable and effective. Data quality. Remember, garbage in, garbage out. The quality of the training data directly impacts the model's accuracy. Cleaning and preparing data is a critical step. Machine learning is everywhere. It powers personalized shopping experiences through product recommendations, advanced medical diagnostics, predicting diseases from patient data, smart assistants like Siri that get better at understanding your voice over time. It's not just a buzzword, it's the driving force behind much of today's AI innovation. In the next slide, we'll explore data science careers, highlighting the skills and opportunities in this exciting field.